Hello everyone, I am Disha Purohit. On behalf of my co-authors, I would like to present the work titled Employing Hybrid AI Systems to Trace and Document Bias in Machine Learning Pipelines. This work is partially funded by No Bias and TrustKG projects. The following agenda covers the topics which will be discussed in this video. Let us start by briefly discussing the graphical representation of the proposed approach. Let's get started. This graphical abstract visually summarizes the key aspects addressed throughout this work. The comprehensive documentation of bias across machine learning pipeline is not available in the state-of-the-art approaches. Furthermore, these approaches do not provide documentation artifacts in a machine-readable format. The absence of these aspects in current documentation efforts can hinder the reliability and interpretability of machine learning models. As illustrated by the case study of detecting fake news, the datasets encompass information about news publishers, news users, and credibility. The data is then fed to the machine learning models for classifying the news into fake news or real news. The dog bias system can identify and detect potential biases during the data ingestion phase, which is the process of obtaining, importing, and processing data for subsequent use or storage in a database. This occurs before the data is provided to the machine learning model for classification problems. Moreover, the integrated hybrid AI system, dog bias, employs probabilistic soft logic, that is PSL, to document the bias identified. PSL is a machine learning framework for developing probabilistic models. PSL models can be defined using logical syntax and optimization. The traces are semantified into a dog bias knowledge graph to document the identified bias in the prediction model pipeline. In addition, various bias metrics are employed to identify the special factors that contribute to the occurrence of bias at a granular level. Furthermore, the dog bias knowledge graph can be utilized to analyze the impact of the discovered bias based on various parameters and factors. In contrast, the principal hybrid AI system employs ensemble learning techniques such as decision trees and random forest algorithms to identify the features that are crucial for the classification of news as either fake or real. Interpret Me as an analytical tool is designed to trace and explain the predictive models which is utilized in the principal hybrid AI system. Moreover, the use of Sparkle queries enables the discovery of impact of bias on behavior of predictive models and the affected outcomes due to the presence of bias in the input data. The objective is to employ a hybrid AI system to trace and document bias in datasets and the predictive AI models. Considering our use case of fake news detection, news platforms and sources can often introduce bias through various mechanisms, intentionally or unintentionally. Media owners and advertisers can influence news content through various means. For instance, a news organization owned by a large corporation may avoid reporting on issues that could harm the parent company's interest. Therefore, a hybrid AI system is required that can effectively distinguish between real and fake news, helping to mitigate the spread of misinformation and enhancing public trust in media. Specifically, we implement our proposed hybrid AI system with a use case based on fake news classification to demonstrate the viability of dog bias, documenting and tracing bias. For the implementation of integrated hybrid AI system, we use the classifier that resorts to the probabilistic soft logic, PSL. A model in PSL is defined through a set of weighted first-order logical rules where the weight is learnable. Then, based on the input data, some random variables are observed while some are unobserved, with the task of inference in PSL being to estimate the value of an unobserved random variable given the patterns learned from the observed variables. The principal hybrid AI system resorts to machine learning technique of random forest for classification. Interpret Me as an analytical tool designed to trace and explain the predictive models is capable of identifying the top-ranking features that contribute to the predictive model's outcome. The predictive model pipeline and the input data are both traced and cemented into the interpret me knowledge graph. Further, the identified biases are traced and documented into the knowledge graph to assess the impact of measured bias on various factors across the machine learning pipeline. This figure depicts a design pattern that models a dog bias hybrid AI system. This design pattern comprises input in the form of data or symbols, models and processes, output in the form of symbols, symbols documenting bias, and symbols representing factual statements of a knowledge graph. This hybrid AI system is defined by four basic design patterns. First, tracing and predicting. This pattern models a system that solves the machine learning problem. It receives input and trains the model based on the training data. An inference process allows for the generation of predictions as symbols. In tracing and documenting bias, the pattern describes a system designed to capture knowledge about bias patterns in both the input data of a AI system and the generated training set. Here, the tracing models defines the family of bias measures and identifies specific bias aspects to be traced within the input and training data. Lastly, explaining bias impact depicts the output, which is a set of factual statements that document the identified bias insights supported by the bias measures. Leveraging the capabilities of PSL as logic and statistical relational learning framework to present the integrated implementation of dog bias approach, the proposed hybrid AI system first traces the PSL implementation of the AI model for fake news detection, that is the training and predicting pattern represented in this design pattern. Then the system uses the tracing and documenting bias in the input pattern, collects all the features that describes news publishers and users. Lastly, explaining the bias impact pattern documents the identified bias in the integrated approach. System interpret me that follows a principled approach that combines data dependent frameworks, that is machine learning model over knowledge graphs, to yield fine grained representations of the machine learning models and to improve the interpretation of their produced outcomes. The design patterns for principal hybrid AI approach demonstrates the workflow of interpret me pipeline. In the training layer of interpret me, the pipeline as an input accepts raw data about news, users, and publishers from two different benchmark datasets. Interpret me as a pipeline offers ensemble learning techniques such as random forest and decision trees. Additionally, the pipeline provides lime interpretations, that is, the interpretation of each news locally involved in the prediction task. In the tracing and documenting layer, interpret me traces all the metadata such as input features, model selection, hyperparameters, prediction, the result of lime interpretation. For documentation, the pipeline utilizes RML mappings to semantify the results obtained and generate the interpret me knowledge graph. Moreover, interpret me facilitates the visualization of decision trees and feature importance plots to understand the trained predictive models. Bias measures. Overrepresentation bias. Overrepresentation bias refers to a type of bias where certain groups, perspectives, or types of informations are disproportionately represented in a dataset, media coverage, or other context. In-group bias. In-group bias is a form of social bias where individuals preferentially treat or favor members of their group over those of other groups. This bias can manifest in various ways such as judgments, behavior, and decision making. Activity bias. Activity bias refers to distortion in data or perception that arises because of an uneven activity levels among different groups or individuals. This table presents an overview of both implementations based on selection of properties to facilitate further comparison. The comparison between integrated hybrid AI system and principal hybrid AI system utilized in the dog bias system is performed here. As we can see, the input of integrated hybrid AI systems are datasets and first order rules, whereas for a principal hybrid AI system, it's dataset. The learning approach for integrated hybrid AI system is probabilistic soft logic, PSL, and for principal hybrid AI system is ensemble learning, and the bias metrics are utilized in both the approaches, that is overrepresented matrix, similarity matrix, and frequency matrix. The research questions for the work are as follows. Research question 1. What types of bias patterns are observed across the machine learning pipeline? Research question 2 is, do bias patterns impact the model performance? Research question 3 is, are the biases traced during the data ingestion process, that is the input, are similarly present in the output? Furthermore, the models utilized for integrated hybrid AI systems are probabilistic soft logic models, that is PSL, and for principal hybrid AI systems are different ensemble learning techniques. The table shows the benchmark utilized, that is BuzzFeed and PolitiFact, with the statistics of the datasets in various scenarios. These are the three scenarios that are used to evaluate the impact of users and publishers on the outcomes of predictive models. Scenario 1 represents the original distribution of the study to state-of-the-art benchmarks. Scenario 1 involves the proportion of users on the benchmark higher than that of the publishers for sharing news. This figure depicts the interaction between the publisher news, users and news, and the values of min, max, and average represent the out degrees from the class I to class J. Scenario 2 extends the dataset scenario 1 and comprises an equal number of users and publishers in the dataset. Scenario 2 consists of more publishers than users. The dataset comprises an imbalanced distribution to investigate publishers' bias in classifying news as fake. Scenario 3 also extends datasets in scenario 1, but it is composed of increased number of publishers from the original dataset. Scenario 3 comprises the equal distribution of users and publishers count. This distribution provides a fair comparison for the evaluation of machine learning models' performance between the publisher news, user news relationships. Results in the integrated approach. The figure demonstrates the distribution of various input variables across both datasets, BuzzFeed and PolitiFact, where figure A and B represents distributions of news shared and the news shared by publishers. However, figure C depicts the distribution of users sharing more than 3 news, and figure D represents the distribution of user news interaction. Based on the aforementioned input variables, the probabilistic soft logic model learns the distribution and predicts more not credible instances. Here, blue represents credible, that is real, and red represents not credible, that is fake. In our experiments over principled approach, we utilize both models and show the results here with BuzzFeed dataset and the results of random forest model are represented in terms of precision, recall, and F1 score across various scenarios. Here in scenario 1 and 2, we can see that the model does not suffer from bias in comparison to scenario 3, where our number of publishers are equivalent to users. Thus, the model learns such distribution and suffers from potential bias. We also demonstrate the decision tree results, which are based on news publishers and users and their credibility score. The decision tree serves as a guide to analyze a decision-making system. And we can see that in BuzzFeed dataset, the most important feature is publisher 19 and highlights that if the publisher has a credibility score of 0.0, then they are most likely to publish fake news. We also report Pearson correlation analysis that sheds light on the impact of features like user and publisher credibility in the decision-making system. And to conclude our work, the dog bias approach is evaluated through two implementation, that is integrated and principled hybrid AI systems. And we have demonstrated that the potential biases are measured over the machine learning pipeline and are documented in the knowledge graphs. In future, We will reuse our approach to trace other predictive tasks, example link prediction tasks. Thank you for your attention. This is the link to our GitHub repository where the implementation is publicly available.